right now we have another lightning talk, and Andraž is going to talk about practical closures. Basically how to run an external process in a readable way. So let's see what that means exactly. And are you ready?
I am. I hope you can hear me. Okay.
Yeah, we can hear you.
Can you see my screen?
Yeah.
Yes.
Yep.
Yep, it's up. Awesome. Yeah, hi. So I'm Andraž. I'm primarily a DevOps cloud engineer, but I've been coding Python for the last 10 years, I guess. And I wanted to cover basically a feature in Python or a behavior in Python called closures. So to get us started and to activate our minds, we will take a look at this awful code. So we have a function called sum2, and it gets a parameter called b. But it also gets a variable from its outer scope. So we have the local scope of the function, but a, which is 2, is defined in the outer scope from the perspective of the function. And if we call the function sum2 with the argument 3, it returns a 5. So nothing magical. So what are closures? And the official definition is something like this. A closure is a function object that remembers values in enclosing scopes, even if they are not present in memory. So what does that mean? So here is another function. So a function that the only thing that it does, it returns the inner function. So inside of it, there's another function. And what this function does is it gets a value. And if the value is greater than max value, it will raise a value error. Otherwise, it will just return the value. But the catch is where it gets the value. So the value is actually the parameter from the outer function. And if we pass in this max value, it will be basically registered here, or it will be like a local variable. But from the perspective of this inner function, it's in the outer or enclosing scope. And now the question is, when we return this function, so the inner function, what will the max value be? And it turns out that what closure does, when this inner function is returned, it will actually have the value that was passed in here. So for example, we pass in a 42, and this max value here gets configured. And when this inner function is returned, this max value will be 42 from now on. And an example when to use this is, for example, you want to date somebody on Tinder, but you have this hard limit not to date anyone that has a shoe size greater than 42. And what you can do is you can call get max value validator 42, and you get a new function. And if the value provided is below 42, you will get the value. Otherwise, this function will raise a value error. So because this is a very common thing in Python, that the only thing that you want to do.
Okay.
Yep, there's some noise.
So
yeah, so because this is a special case, or a common case when we are using partial is, so just to fixate one argument of a function, Python has a built-in function that can help us with it. So if we write the same validator a bit differently, like this, so just as a normal function with the value and the max value here, with the partial function, we can basically fixate the max value. So here the function has two parameters, or the arity of two. But when partial is called, it will fixate the 42 here, and it will return a new function which will be the same as this function, but with max value 42. So this parameter will go away. Here it will just be replaced with 42. And that's also implemented basically with closures. So you can look up the documentation and you will see the documentation of this function partial, but also the implementation. And a lot of times I see code like this, which is, of course, you maybe get a logger, but then you have a lot of function calls that basically have the same arguments to the function call. So you will see this subprocess run, and then people will also always say capture output true, because the default is false. And if you want to get standard out or standard error, you need to put this to true, and then maybe some common environment variables that you want to put in the current working directory, which can be a temporary directory that you just create here. And you will see this through code a lot. And before each of those calls, you will definitely then see, yeah, so some logging to log that was actually called, and then maybe logging out the return code or standard out or standard error. And a way to address this would be something like this. And you can say that this is basically a function factory, so a function that returns a function. You can say that this can be done with a decorator, but another approach how you can look at this is also the usage of closures. So we have a get docker command, and we can pass in a dictionary which has environment variables. And in this line, we basically say that, yeah, we want to have this path as a common one, but we want to also add the ones that are passed here. And the inner function is basically the same function that we saw before, so some logging, then the actual call of the docker command. But the most important thing here is, here you can say, you can basically fixate environment variables for every call that the docker command will then that you will make with the docker command. Here you can basically, when this outer function is called, you can, every time you can create a temporary directory, and this environment will then be fixated or fixed here. And yeah, if we take a look, we can then say get the docker command, and you get a new function, and you then just call docker command image ls, and yeah, also this environment will be basically, yeah, this command is configured with this environment dictionary. The important part here is that what are the arguments here or parameters here, it's up to you, right? It can be, you can pass in environment variables, you can pass in a current working directory. You can maybe decide that you want to have a current working directory, so you can create it on the fly inside the get docker command. So that's completely up to you. But I think that this can help you out clean the code. So yeah, that's it.
Yeah, thank you. That was very interesting, but I will purposely hold myself back on questions because I just found out that we have another talk. So yeah, let's just discuss this after, just so we're not, yeah, just so we're like good on time. And Dror.
Okay. We have some time just before the breakout room. So if you have a question or anyone, this would be good. If you have a question, you can also put it in the chat.
But we have another talk, right?
All right. All right. So let's do the talk. All right. So
I don't
we
know
have.
that, whatever you think is best.
All right. We have one. So we have a comment by Peter, don't use mutable default args, though Andraž doesn't use it inside, right? In that
yeah, I mean, it does not update it, so but it's a booby trap.
It is a
yeah.
booby trap.
Also syntax, don't use that kind of syntax, but use it if you want to fit it on the slides, right?
Andraž, here's an obvious question. How would you explain the difference between a closure and a decorator in the simplest possible terms? And you can also, if you'd like, you can also talk about best use cases for one or the other.
So, well, decorators are basically in Python considered a syntax sugar, where you pass a function into a function, and then you return something. So can be a modified function or whatever. So actually, the add is not really needed in a way there. Where closures is a feature commonly found in other programming languages as well, especially where functions are first-class citizens, meaning that, for example, if you can return a function from another function, then this behavior is very common. If you think that, like, if you can find a good way to use closures or to write something like that, I would still recommend you that you, for example, start with try and play around with the partial function. So you can find it into the built-in functools module. So there's this partial function. And it can be super useful. For example, what I really like to do, and I think it's a nice thing, is you write a simple max value validator, and then I use partial, and I set, for example, the shoe size should be 42, and I try to, on one hand, I have a validator for max value with a fixed upper limit, and then on the other hand, I try to do something that is domain specific. So on one hand, I have something more technical, but then I say this is just a max height validator. And in most of the cases where I do that, it's much easier for people to understand the code. So if you, for example, have a code with a lot of a lot of validators, and you always put in 100, 100, 100, and then the values in, like in a file, people will be, oh yeah, what is this 100? But if you just say, yeah, it's just the max age should be 99, for example, and you say just max age validator, or yeah, something like that. I really like to play around with this. And another great use of partial function is if you try to get familiar with dependency injection. So that's another technique that you can use. You will commonly use it with the PyTest testing framework. There it's used in a bit a different way, but what you can say is, for example, you have a function that needs to send some data to S3, to AVS S3. And inside of that function, you actually don't want to call the library for sending data to S3, which is Boto in most cases. And what you can do is you can pass the handler how to send that data on as a function parameter. You just say send away this data provider, and you call it in, and then you can implement different data providers. And one would be the actual S3 one, and you can fixate that with partial. But another can also be, for example, a dummy one. So another use case of having closures and partial is also you can control a bit more where you do imports of libraries that you maybe don't want to import. And if you are interested in that, I can also have like a larger talk on that topic. Yeah.